In this session, I'm going to look at vectors and different vector related functions in R. One of the important aspects for R programming language. So if I have to define a vector, any variable with one or more values of the same type. That is what we are calling as vector. So one or more values of the type numeric, one or more values of the type logical, right? And one or more values of the type factor. So the type could be anything. One or more variables of the type character. Sorry, one or more values of the type character. Any of these, or there could be many more types. Integer. One or more values of the same type, we are calling it as a vector. The easiest way to denote a vector in R, right? If I am saying X is a vector containing a few values, let's say the numerical values 1, 1 to 5. This is a vector. X contains numerical values 1 to 5. So X is this, or probably if I am talking of class of X, which will give me the type of it, it is giving me integer, right? Whereas the same way I can have I can have a variable X containing strings. So ADAS, some other. So now if I am looking at X, these are the variables, and if I am talking about the class of X, it's a character. So these are all vectors, right? So one of the easiest way is find out, you take a variable name and assign values to it through a C function, which is a concatenate function. And if I can check out the class of that particular function, in some cases it gives me integer, in some cases it gives me character, but all of them belong to one single class, right? Now when I am doing a length, I can do some functions on the top of it. When I say length of X, it gives me how many typical values are there with respect to X. So how big is the vector? It comes through the length as a function. And I can do a lot of things. If my vector is consisting of numbers, right? Here my vector is consisting of characters. So probably I can't do a mean on it. It gives me NA because none of them is a number. Whereas if I create another vector Y containing values, okay, 23, 463, 3, 6, 35 something. Now let me find out what is the length of this vector. Length of Y tells me it is 5, right? Now let me find out what is the class of this vector. The class it finds it's numeric, fair enough. And let me try finding out what is the mean of this vector. 106, the average value. I can find the sum of this vector. I can find the median of this vector. So many calculations I can do. I can find the minimum value of this vector. I can find the maximum value of this vector. A lot of these calculations can very well be done on the vectors. So all the values which are in the numeric form, if the vector contains the values in the numeric form, I can very well do all these kinds of calculations on the vector. Now there is a different way of, another way of entering these values. Here we have entered them as a C function where each of the values we have used like this. Now there is another way. Let's say I am defining some vector called Z. The Z, I can use a function called scan. When I am using a function called scan, now you see that I can enter the values directly here. Okay, the first value is 23. I press enter. I can enter the second value, 463. I can enter the third. I can enter the fourth, I can enter the fifth. Like this I can keep on entering. Now once I come out of it by pressing one more enter, it says that there are 5 items that it is reading. So this is another way I can get my Z. My Z is containing the values, but the only difference is here I have entered them directly one after the other rather than using some kind of concatenate like this. Both of them mean one and the same, but there are different ways of entering the values associated with a vector. Now, if I have to pull out some elements of a vector, right? So let me do one thing. We will put, okay, here itself. Let's do something here. I want to pull some of the values of the vector. So here let's look at extracting some of the elements of the vector. So let's define a much proper vector, right? Let me say x is a vector from taking the values from 1 to 10. So if I am defining x, it's 1 to 10. Now anything, if I want to extract some subset out of this whole vector, I want a subset of it, then we will be using the square brackets, right? Whatever we write in the square bracket, it's like it will extract a subset of the vector following some condition. Now if I say x of 4, means the fourth element of this vector will be extracted for us. So the fourth element is 4, or probably let me define x for your clarity. Let me define x from 11 to 20, so that we will not confuse with the same serial numbers. Now if I am saying the fourth element of this vector, so I'll put 4 in square brackets, then it gives me 14. So if I have to extract one element of a vector, I can simply give this kind of a notation. But if I want to extract more, let's say I want to extract the 5th, the 7th and the 10th elements of the vector, then I'll say x. So inside I'll define a C function. Okay, I want the 5th one, I want the 7th one, and I want the 9th one. So these three I'll enclose in regular brackets, whereas the extraction I'll enclose it. So it takes x of 5, which is the 5th element, x of 7, the 7th element, and x of 9, the 9th element. So we are getting the output as 15, 17, 19. So if I have to extract more values, I can use this kind of a mechanism. Now, let's say I want to extract all the values but not the first value. Then I can say x of minus 1. So minus is like dropping, right? Whenever I am showing something in a subscript, which if I am showing a minus sign, it means that I don't want that value. All other values I want to get. So it gives me 12, 13, 14, 15. So if I am saying x minus 5, it will give me 11, 12, 13, 14, 16, 17. So 15 is missing because the 5th element in that list is 15. So it will not display the 15. Remaining elements are being displayed. Similarly, if I want, I don't want, let's say, the last element of x. So if I know that the number of elements are 10, then I can say minus 10. But otherwise, even here, I can compute what is the length, right? I can very well compute what is the length of x. The length of x will work out to 10. So I am giving x of minus 10. Means I will get only 11 to 19. And let's say I don't want the 1st, 4th and the 9th values. Then I can say x of minus, I'll define a C. I don't want the 1st one, I don't want the 4th one, I don't want the 9th one. So it will say x of minus 1, x of minus 4, x of minus 9, which will remove those 3 elements 12, 13, 15, 16, 17, 18, 20. So this is how I can extract some of the values, right? And in some cases I can give even a sequence. If I want the first 5 values, I can define a sequence also internally. So I can simply say x of 1 colon 5, the sequence I can use internally. So which will give me the first 5 values associated with x. And any of these, right? So sometimes I want even numbered values, right? I want only even numbered values. Let's try. So we know the sequence, we can work it out. So sequence from is equal to 2, or probably we can directly give 2 comma, that's the from number. Then what is the 2 number? 2 should be like, I want to know what is the length. So I'll say length of x. So from 2 to the length of x, increment by 2. So this is what this kind of values I want to extract. So I'll get only the even number of values, even observed values. So second value, fourth value, 6, 8, 10. So different ways of extracting values, elements from a vector. Alright. Then I want to know the next part, the different classes of a vector. We see that there are 6 major classes a vector can belong to. Logical, especially if there are true or false kind of outcomes. Then the type of that vector will be logical. Integer, one is if I am defining a sequence directly allotting to a variable, by default the type will be an integer. Or any other numeric, if I have converted it into an integer using my coercion mechanism as dot integer, then also the type will become integer. Real, which will be showing as numeric. Then I can have complex, any complex numbers. Character is a kind of type which is exclusively for string related stuff. Raw is very rare, we'll talk about it slightly later. Right? Now, let's say we have this vector. Right? We have created x as a vector. Now I want to give some names to this vector. Right? So I'll say names of x. I'll give some kind of names to this x, wherein I want to give some kind of name. So I'll say, probably let me call it first, second, these are the names that I'm giving. Third, so one by one it is allotting. Fourth, fifth, sixth, seventh, eighth, ninth, and 10th. So these are the names that I am giving to my vector. Right? The names of x I am giving like this. Now let me display what this x is. Now you see, you get the names first, and corresponding to the names you are getting your values. So this is a way where you can even define the names to the vector. Right? Then if I want to remove the names, again you do the same thing. Make them as dot vector. So the moment you are making as dot vector of x, so the names are removed and only x is being displayed. So either I can add the names or remove the names. If I have to add the names, I have to add it as names in bracket, show the name of the vector. Now, in some cases, I can have the logical subscripts also. This is one aspect where I am giving a name to my vector. In some cases, let's say I want a logical subscript. When I say logical subscript, let's say these are 1 to 10 that I have. I want to add those numbers, right? We have the numbers 1 to 10. I want to add up all the numbers where x is less than 5, right? So if I say sum of x less than 5, let's see what is coming. It's giving me 0, right? Because x less than 5, sum of x less than 5, because none is less than 5, I'm getting it as 0. Let's say sum of x less than 15, I'm getting it as 4, which means what is happening here? First let's try x less than 15. So x less than 15 will evaluate as true, 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 false, 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 false. So when I am doing a sum on the top of it, as we know, true is being coded as 1 and false is coded as 0. The summation is happening on ones and zeros. So the summation of all the ones is coming out to be 4. So it's not actually adding 11 plus 12 plus 13 plus 14. Now this is where, if I really want to do that kind of an addition, what I do is I'll take the sum of x where x is less than 15. Now what is happening? I'm taking the subscripts inside. So I'm creating a subset of the vector x of, internally I'm giving a rule, x should be less than 50. So I'll get the subset where this particular rule is being met, and once I get that vector, I'm taking the sum of that. So probably if you want to check it, don't put the sum, you simply put x of x less than 50. What is it coming out? It's showing 11, 12, 13, 14. So that's one I want to do a summation. So you can do stepwise also to understand what is coming up. Sum of x less than 15, which will give me 50. So that's how I can use even the logical kind of a subscripts also. I can really see that only if they are so if I want to add all the even numbers only, right, then what is that I can do? I can say sum of x. Now I require only even numbers, right? So x, I'll take the modulo, percentage 2 should be equal to 0. So wherever the x percentage 2 is equal to 0, whatever comes on the top of it, I'm doing a summation. So it is becoming 12 plus 14 plus 16 plus 18 plus 20, which will be working out to 80. I'm only adding up the even numbers here. So we can really give different kinds of conditions, and on the top of that extract the values using the subscripts, and on the top of that do the necessary calculation. Now the next thing, sorting. If I want to sort the whole x, right, I'll simply say sort x, which will give me the sorting in the ascending order. But if I say reverse, right, if I say reverse of sort x, REV, then I'll get the sorting in the descending order. So the typical sort will give me the ascending order, and the reverse is giving me the descending order. Now if I want to add the top 3 values, probably I can do it sum of the reverse sort. So when I am doing the sum of reverse sort, actually all of them are getting added. Now I am getting a vector which is 20, 19, 18, so on. Now of that vector, I want only the first 3 elements. So that's where I'll put 1:3. Right, sum of the reverse sort. So probably it's better that I put the sum button, there's a sum bracket here. I'll do a reverse sort first. Reverse of sort is a vector. From that reverse sort, I'm pulling up the first 3 elements. and on the top of that I am performing the sum. What went wrong? Let's see something reverse sort. So the reverse also should be in bracket. Let me try. Sum, right? Let's first do something internal. Reverse sort. Oh, there is no y here. I did not give x. Sorry. Sum of reverse sort of x, right? This is the x and this is reverse. So I have to do sum, not AUM. Sum reverse sort of x so there is a reverse sort of x where I am putting 1:3. Where is the bracket missing? Okay, so I'm taking the 3 in the reverse direction. So there is a summation of the 3 in the reverse direction, which is giving me 36. Why is it giving me 36? So it is taking the actual sort. Okay, 11, 12, 13 is what it is doing the addition. So let me do the reverse of sort, reverse sort of x. So when I am doing a reverse sort of x, I am getting this. So reverse sort of x, when I am putting 1:3, I am getting 20, 19, 18. And now on this, it's better to do a step-by-step stuff. I do a summation of this. I'm getting 57. So it's better to do step-by-step until you get the hold on it in terms of integrating all of them. First do a sort, then do a reverse sort, then take only the top three, the first 3 elements, and then you can do a summation on the top of it. Right? Now, if I really want to know which value is containing the maxima. So how do I say which, where x is equal to max of x. So what is it saying? The 10th element of x is containing the maximum value. And I can say x of, so probably if I want to get what that number is, I repeat this part and on the top of it I'll put x in a square bracket. I'll get the subscript associated with this. So which will give me that my 10th value is 20. So I can really try out different kinds. Probably I can get the minimum value. So I'll first find out what is the minimum value, which x equal to minimum of x. So it says the first value is minimum. So I'll bring in this and on the top of this I'll put the x to extract the value. I'll put the x on the top of it, say 11 is the minimum value. So we have different kinds of operations that we can perform on the vectors. We can do different kinds of namings. We can use logic, conditionality as a part of extracting the vectors. We can sort, reverse sort, we can get the maximum, minimums, sum of the maximums, different kinds of functions we can really execute on the top of the vectors. So just as a quick summary, I can find out the maximum of a vector, minimum, sum, mean, median, range. So let's find out the range, right? We'll find out the range of x, which will give me that it ranges from 11 to 20. The minimum value and the maximum value are what are given as a part of the range of x. So it's a vector containing the minimum as well as the maximum. So I can find the variance of x. If there are two values x and y, I can find the correlation between x and y. These two needs to be the vectors of the same size. Then we are trying to find out the correlation between x and y. Then I can sort x. I can find the rank of x, right? So probably if I'm simply saying rank of x, so the first one is having a rank 1, the second one is having rank 2. So this is purely in the ascending order. The rank of x from the smallest to the largest. So I'm getting the rank. Similarly, I can get the order. Probably to know the order as a usage, I'll give one more variable y, where I'm taking values in some different order, right? Probably let me take 23, 42, 12, 60, 6, 31 and 18. Let me take different values here. The reason is when I do a rank of y, I'm getting that this one is the first rank, which is the lowest, and this one is the last rank, sixth rank, which is the highest. But if I'm saying order of y, this is an interesting thing. It says the first thing is 3. Third observation is having the lowest value. Then sixth observation has the next lowest value. Then it is the first observation that has the next lowest value. And finally the fourth observation has the highest value. That is what it means by order. Right? So it will give me the position in the vector where the lowest value, the next lowest value are typically lying. That is what is being executed by order. Then when I am saying quantile, so I'll get few more details here. When I am talking of quantile of x, it gives me all 0 percentile. What is the value corresponding to 0 percentile, which is the minimum? 100 percentile, which is the maximum. What is the 25 percentile value, which is called as a first quartile? What is the 50 percentile value, which is the median? And what is the 75th percentile value, which is the third quartile? So all these 5 are directly computed when we are computing the quantile. And if I am saying cumulative summation, right? Probably if I use sum, cumulative summation, let's say of x, right? What it gives first, if you see, okay, first one 11, then 11 plus 12, 23, 23 plus 13, 36, 36 plus 14, 50. That is how the summations are being done. So when it comes to this number, it adds up all the values which are lower than it. So when it comes to the 10th, 11 plus 12 plus all up to the 10th value. All of them are typically added. So can sum up all the elements up to that particular point is what is provided by sum. Similarly, even if you do it with respect to y also, you will understand it's not in the ascending or the descending order, it's in the order of presentation. Right? The first one is 23. Then the next one will become 23 plus 42, 65. Then the next one will become 65 plus 12, 77, and so on. Right? That is what comes in cumulative summation, and when it is cumulative product, it's just a multiplication of those stuff. Right? All these are different kinds of functions that you can execute on any kind of a vector. Of course, if the vector type is numeric, then only we can execute all these kinds of different functions. Now, a few more interesting functions that come in case of vectors. One, I can take the 5 numbers. So when I look at 5num of x, it means it gives me the minimum, the maximum, then it also takes a slight difference. Instead of exactly the quartile, so it takes the minimum, it gives me the maximum. In the middle there is a median, just like your quantile. But in quantile, here it was Q1, the first quartile, and here it is Q3, the third quartile. Whereas here it computes the lower hinge and upper hinge, which is a slightly different interpretation, which still is computed based on the quartiles itself. So this is a 5-number summary which is generally given, which tells us where the 25%, the 50% kind of observations are lying. Then, now, the most important part is the table. On a vector, we can very well work out a table, right? Table is something that gives us the frequency. Probably here, if I simply say table of x, it gives me different observations and their frequencies. So 11, 12, 13, 14, 15, 16, 20, all of them are coming once only. So let me do something else. Let me take some variable z, right? Randomly let's allot data coming from a Poisson distribution. So random Poisson distribution. Let me take some 1000 observations and let the lambda of it be 1.5. For a Poisson distribution, we'll discuss about it slightly in detail at later point. But right now I'm only interested in looking at the table. It's a very interesting classification, or it's a very interesting compilation that comes with respect to the Poisson distributed values. So it says I'm computing randomly, I'm generating 1000 Poisson distribution values with a lambda of 1.5. So that I am allotting to z. So basically, if I am checking what the z is, I am getting different kinds of values. So there are 1000 values that are generated. Now on this 1000, this is a vector of 1000 values. Now I really want to tabulate this. Now this is where the simple thing comes, table of z. Now it says this is how my distribution is. There are 219 zeros in it. 341 ones are there, 243 twos are there, 143s are there, 41 fours are there, and like this. So in a random way, I have tabulated the whole number of occurrences. So if at all I have a vector and I am using a table, it simply means that I am tabulating all of them and I'm trying to find out the different kinds of summarizations, the total count of each of the occurrences coming up. Now, if I really want some kind of calculations, right, I can very well do different kinds of calculations using some table related, right? I can very well use the table related computations if at all I am having some specific set of data. Let's say I have a table containing month-wise temperatures, right? I have the month-wise temperatures and I want to find out the average of the month-wise. So for that, let me take a data set. That would be much more easier. So let me load one data set called temperatures. So I'll say I'll allot it to some variable called data, right? I'll allot it to some variable called data, right? or probably I can simply read from it. Let me try. Okay, so I'm allotting something called data, where I'm doing a read dot table. I'm reading it from the table, where let's say I have a folder in my E drive called as R course, and within that I have a text file called temperatures.txt. Let me see if I can open that through this command. R course, oh, I have to give double slash. So everything is a double slash. R course double slash temperatures.txt. Now when I am simply loading data, so my data is consisting of almost 6,900 observations, right? So if I don't want to see all, probably I can say simply head of data, which will show me the first 6 observations, right? And now it is showing me V1, V2, V3, and probably the first rows are showing temperature. Rather than that, let me load again my data table with the header equal to true, so that the first row will come out as headings. Now I have to put comma. Right here I'm putting header equal to true. Now this time let me see head of data, which is loading. So with the headings temperature, the lower, the rain, the month, and the year. Now what is that I want is, I want to find out the monthly average temperature. So now this is my table, right? This is my data. Now what I can very well do is, I can typically say T apply, where I want to apply some kind of calculations on my table. So what is the calculation? Which one I have to calculate? Let's say I want to calculate the temperature. Based on what I want to calculate? Based on month I want to calculate. And what is that I want to calculate? I want to calculate the mean. So this is how the T apply works. So T apply is like a table apply. So what is that you want to summarize? Temperature I want to summarize. Then based on what? Month wise. And what is that you want to compute? The mean. Now when you do it, okay, this one, temperature. Okay, so we have to attach the table, sorry. Attach, because we have loaded the data from somewhere. So we are attaching the data. Okay, there is, month is typically must. So we'll simply apply now the T apply this time. Now you see, for each month I'm trying to find out the average temperature. So it says for the month of January the average temperature is this much, for the month of February is this much, right? And if required I can convert it as a data frame also, so that I will get it as a vertical table. So as dot data dot frame I can put on the top of it. So I'll first get the T apply, whatever we have done, and on the top of it I'll put as dot data dot frame, so which will convert whatever the result that we have got into a data frame. So I'll get it in a vertical order so that my comparison is better. I'll say that the January and February and particularly December, the average temperatures are much lesser, and in the other periods they are much higher. The same logic, instead of mean, I can go with variance. Now here I may say that, yeah, in October the variance is much lesser, whereas the temperatures are very, very volatile in the month of May. So some kind of information we can get, especially if I have a data table and I have to do a summarization on that particular table based on one or more variables, then I can use this T-apply. Especially, I'm taking the response variable. What is that I want to summarize? Based on what? That is where I'm taking the categorical explanatory variable. And what is the function? I can use mean, I can use variance, I can use other functions as well. And in some cases, if R doesn't have a built-in function, we can write our own functions also. Right? If R is not having some kind of a function and I require to do something on the top of it, probably let's say I want to do the mean and divide it by the variance. Right? I want to do the mean and I want to divide it by the variance. In that case, I can very well write my own function. Right? Probably here T-apply. Now instead of mean, I'll write my own function x. Right? I'll explain you the way of writing the function. So I can very well write mean divided by the variance. So I have to put it as mean of x divided by the variance of x. Yes. So I'm not just taking the mean, I'm not just computing the mean, I'm not just computing the variance, but I'm taking the mean divided by the variance of x. So like this, we can write our own functions also. A function of x we are writing wherein we are taking the mean of x divided by the variance of x. So like this, we can write our own user built functions also and try to extract the values. Now, if I want to get, let's say, year-wise, month-wise, not just month-wise averages, but I want to see year-wise, month-wise averages. In that case, what I'll do is I'll say T-apply, again the temperature, but because I want in 2 dimensions, I'll mention it as a list. The first one, what is my first variable? YR. YR is the year and MONTH is the month. So I'll give it as year and month. So these two I want as a part of my list, and for that I want the mean. So I'll get it like years 1987 to 2005 for each of the months. I'll get the mean. So probably I'll say in 1987 in January the mean is much lesser, temperatures are much lesser, whereas in 1993 January the temperatures are much higher. The same thing in February, probably 1991 registered a much lower, whereas probably couple of years it registered much higher. Like this, we can very well do this kind of two-dimensional kind of a table also, tabular averages also I can very well apply. Now let's say within this list, I don't want all the years and all the months. I want only all the years but only the first 6 months. In that case, the best way is I'll reapply it, but within this, so the first one, if I want all of them, I'll not specify any, but if I want, let's say, only the first 5 years, right, only the first 5 years and only the first 6 months or 5 months, first 5 years, first 5 months, then it's giving me only the 5 years and 5 months. But if I say I want all the years but only the 5 months, then the first one I'll keep it blank which says it is for all the period, all the years, first 5 months. So it gives me, and similarly if I want first 5 years, all the months, in that case I'll remove this one. I'll just keep comma and a blank. Then I'll get for the first 5 years all the months. So like this I can get some more additional stuff. I can create multi-dimensional tables where I replace the one categorical variable by a list of categorical variables. In case my data has any kind of missing value, right? In case my data has any kind of missing values, the better thing is, if I have to keep myself comfortable against this missing values, it's always better that I separate this with na.rm equal to true. Means remove the NAs and after that you apply whatever the calculation we are doing. So wherever we are writing this na.rm equal to true, it means that any kind of missing values that are there in our data will be automatically removed before any kind of calculation is applied. Now, one more usage is trimming. I want to trim 20% of the data to the left and to the right before I do any kind of computation. So if I want to trim some percentage of data, right? So here, let's say I want to trim 10% of the data to the left and 10% of the data to the right. The extreme 10% of the values on either side I want to remove, and after that compute the mean. So I may get a slightly different values because I have removed 10% of the data from both the sides. Now you see here the average is 3.17, but after I removed, the average became 3.26. Here also the average was 8.04, but after I did the trimming it became 8.15. So after I removed 10% of the observations both on the left and the right, if I am computing the mean, I can very well use the trim. So one of the very important functions that I can use on the tables is the tapply function, which can work very heavily on the table, right? Now, other important functions that I can very well compute. Now I want to do some kind of an aggregation. Another important function that we can apply, right? So wherever I am doing aggregate y to x 1 to 1, so probably I'll take one example, right? That based on that example, we will try to execute each of these usages of aggregate, right? So let me load this single data file. So let me call that data file as data again, read.table, right? I am doing a read.table e colon, what is I have in E, I have R course, and within that I am taking the file called phdapnia.txt. This is the name of the file that I am loading. Yes, so probably if I want to, it's better that I load it with a header, right? So probably what I'll do is I'll add to this, I'll say header equal to true. So I can get the head of data, which gives me this is the head. Now I'll talk about these four kind of aggregates, right? Now I know this is my data, growth rate, water, different kinds of waters are there, different types of detergents are there, different Daphnia clones are there, and the pH values are there. Now, when I am saying aggregate, so one-to-one kind of a relationship, I want to aggregate within my data file. Within this data file, I want to do an aggregation between my response variable and one categorical explanatory variable. Because if you look at the different levels associated with water, right? If I am looking at the different levels that are associated with water, there are 3-4 levels. We'll see what are contained there. So I will simply say aggregate, and I'll use y, which is my, what is that I want to summarize, based on what I want to summarize. Here y should be a kind of response variable, which should be more like numeric, and x should be a categorical variable. If I am picking it from a data table, a table like this, it should be more like a character or a string kind of a variable, right? So that's the reason I have taken growth rate and water. So here I am looking at y colon x on my data, and what is that I really want to calculate. So let me try that. Aggregate. Now growth rate is the response variable I'm looking at, and the model that I'm building, so that's where I'm using the tilde sign. So the growth rate versus water on my data file. Data is the name of the file that we are reading, and on the top of it, the third thing is I'm aggregating what. What is my aggregate meaning? Mean, variance, all these things can be done. Now when I'm doing an aggregate, yes, there are two types of water, Tyne and Weir. The mean growth rate in case of Tyne is 3.68, in case of Weir it is 4.01. Now the same thing I can do probably, instead of water, let's say I can do something else. Another explanatory variable I can use, probably I'll call it detergent. So I'll look at the growth rate based on the detergent. So for brand A, the growth rate is this much, for brand B, the growth rate is this much, for brand C, brand D. So there is a kind of a summarization that is coming out where I am getting the mean. That is one way of summarization where it is one-to-one. Then I am summarizing based on two explanatory variables, x plus y. So water and detergent put together. So this is where instead of just taking detergent, I'll take it as water plus detergent. So you'll get all combinations. There are 2 waters and 4 detergents. So 2 into 4, 8 combinations I'm going to get. Tyne and brand A, this is the average. Tyne and brand B, this is the average. Tyne and brand C, this is the average. It goes like that. So this is like one to many. And if I'm going with many to one, so in the response variable, there are 2 response variables. So I want to look at both the growth rate as well as the pH, right? So if I want to do that kind of a work, for the y variable, I'll not do x plus w. I'll join them using a C bind. Column binding is what I'm going to do. So I'll say aggregate, right? Instead of growth rate, I'll put C bind. Along with the growth rate, I'll also add, what is that? pH. I'll also add pH along with the growth rate. So I'm doing both of them, right? I'm doing y variable also more than one, x variables also more than one. Y variables more than one happen through C bind, whereas x variables more than one, they can be handled through a simple summation. Now you'll get For each time and brand, we are getting the growth rates as well as the average pH. So we can use aggregate for lot of such kind of application. Another very strong usage of the vectors, and it's as good as your Tapply, but in a slightly different way, especially when I want multiple kind of things also to be displayed and summarized. Then this is a very interesting thing, parallel minima and maxima, right? So when I'm saying, let me keep this very interesting. So I'll define three variables, x, y, z. So x, all three I'll put random numbers, 10 random numbers is what I'll take. So x I am taking run if 10, y I am taking some run if 10, and z also I am taking run if 10, which means these are three different random variables. So x is having these values, y is having these values, and z is having these values. Now if I am saying p min of x comma y comma z, it does a parallel minimum, okay, in this x, y, z, first element, which is the minimum, this is the minimum. Whereas in the second element, which is the minimum, this is the minimum. In the third, this is the minimum. Fourth, again this is the minimum. But fifth, this is the minimum. All these values are typically displayed. So when I am saying P minimum, parallelly the minimums of each of the subscripts are computed and displayed. So minimum value from any one of the three variables for each of the subscript is computed, and what is coming out is a kind of a vector for us. So P minimum is more like for parallel minimums, parallel maximum. I can get a P max, but that's a very interesting function to really look at. Now, the other important functions to look at, okay, the addresses with the vectors we have already looked at, right, which is something that will give me the address. So that's fine. Now similarly, let's say I have defined these. Now I want to know which within this x is very much close to, let's say, 0.5, right? Within this, all these things, I have so many values that I have generated for x. I really want to find out the closest value. Now this is where what we take is, I'll find out the absolute value of x minus 0.5 and I'll equate it to the minimum of the absolute value of x minus 0.5, right? So I'm trying to find out which x minus 0.5, I want to really see which one is the closest. So I'll take the absolute value of the difference between x and 0.5. So I want to know which one is closer. So I'll look at the difference, which one is closest to the minimum of the absolute value of x minus 0.5. So which one is this? It says the fifth element. Okay, this is the fifth. The fifth element contains the minimum value. Now what I can very well do, I can very well surround this with x to get what the actual value is. I'll surround this with x, says this is my value, and probably by how much it is lesser, all that stuff. So if I want to find the closest value in a particular list to anything, I can find out the absolute difference between each of the values and that particular value, and I can compare it with the minimum values of all those differences. So even that's one more way I can get the specific set of values. Then a few other things we have already looked at. We have done the ranking, we have done the sorting, we have done the ordering. So all those things we have already taken care of. So I don't need to again specifically get into that. right? Sorting is doing the sorting in a ascending or in a descending order, because when I do a reverse sort, it becomes a descending order. When I do a proper normal sort, it's in an ascending order. But when I do order, we have already said, when I am doing an order, the result that comes out is, in the result, whatever is the first value that comes out, this value within my original data, if the result is coming out as 3, the third value will typically have the least value. If the next is 6, then the sixth value will be the next highest value, and so on. So in the order, we are getting an integer vector, a permutation that will sort the input into the ascending order. So that's one thing we have to differentiate with respect to the order. Now, the other set of things that we can perform on the vectors, if there are duplicates, I can first of all get the unique values. Let me just try it again. Let me take something data, right? Let me take a data where I am taking a Poisson distribution, random variables, 1000 observations. Let's say 1.5 is my lambda value. So if I look at data, these are so many observations, right? Now I really want the unique values. So I'll simply use unique of data. So all the duplicates will be removed. So it gives me 0, 2, 4, 1, 3, 5, 6, 7. These are the unique values, right? Now I can also get what are the duplicated ones. Okay, duplicated of data, which will tell me for each of them whether it is duplicated or not. So the first one, here it is not duplicated. Probably let me generate a smaller list, that would be more easier. So let me call data, the same Poisson distribution. I'll generate just 20 values with the same 1.5. So now when I look at data, these are the values. So if I generate unique of data, it says the values are 120436. And if I am doing duplicated of data, so for each one it says, okay, the first one is not duplicated, 1. The second one is 2, so it's not duplicated. The third one is also 2, it's already duplicated, so that's where it is showing true. The fourth one is 0, not duplicated. The fifth one is 0, again it's duplicated. So this is what is the outcome that I am getting out of duplicated. Now if I want only my non-duplicated values, so on the top of this duplicated, all I need is the data and I'll put not. Not duplicated is giving true, 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 false, true, the opposite of the duplicated data. And I'll come and I'll enclose this as a subscript to my data. So finally I come to the end and I close this, so I'll get again the same order, 1, 2, 0. So basically unique of data is same as data of not duplicated of data. So these two give me the same result. So that's one more way of trying to work out. Then in some cases I may be interested in finding out the number of runs. Means probably if I have my original values, okay, here, okay, 2 is repeated 2 times, right? Then 0 is repeated 2 times. Then 1 is repeated 1 time. 2 is repeated 2 times. 4 is repeated 1 time. This is what we are calling as runs. So what is that I can do if I really want to find out what are the runs that are there? I'll put RLE. RLE is a function which will give me the runs as a part of my data. So it says there are 17 different runs in this. Okay, first the numbers are 1, 2. Okay, 1 is repeated 1 time. 2 is, after that 2 is repeated 2 times. After that 0 is repeated 2 times. Then after that 1 is repeated once, 2 is repeated again 2 times. 4 is repeated once, 0 is repeated once, 3 is repeated once, 2 is repeated once, and so on. So there are 17 such kind of runs that are existing. Then if I want to find out what is the maximum, what is the longest run, so basically it's like a list. So I really want to find out of this which one is the maximum. So let me do it with slightly more values, right? Data, so probably I'll do a data assigning where I'm doing again a Poisson distribution, but probably with 1000 values and 1.5 being mine. So now if I really want RLE of data, so it says there are 769 runs. So 2 is repeated 2 times, 1 is repeated 3 times, 0 is repeated 1 time, and so on. Now all I really want is, I really want to know what is the maximum value, right? And I want only the length. So this is where I'll say RLE data is giving me this. So within this RLE data, so because it's a list, I'll access it through double square bracket. So when I say RLE data and 1, only the first line of the list is going to come. Alright. So it's only telling me 2, 3. So these are the numbers that are typically coming out. Now for this I want to find out the maximum value. Okay, I'll find out the maximum value of this. So there is a maximum value 5. Now I want to find out which one has that maximum value. So that's where I'll simply use on the top of it which one is containing this, right? So the maximum value I have found out. The maximum value I have found out. Okay, so I have to really equate, right? Instead of saying which is 5, so I'll say which is equivalent to maximum of 5. So I'll simply say, so instead of only saying which of maximum, I'll simply say which contains RLE data 1 is, where is it equal to maximum. So I have to put double equal to, right? So which value of that RLE 1, I'm trying to equate it to the maximum. So the 1/60th value actually contains this. So I know which one is having which run, which variable, right? Which variable is typically having this. And if I want, I can even bring out which variable. Now 1/60th run actually contains 5 number of times. Now I really want to bring out what is that value, which means I have to bring out from the second one. So I'll say, I can very well say RLE, right? I can very well get from this, I want the second element. So I can very well say which one is the 1/60th element, right? I can very well retrieve the value associated with the 1/60th element as well. So what is that I can do for that? I can really get RLE of data. I can get RLE of data. So out of this, get the second list, and out of this, get the 1/60th element. So instead of 160, I can even write which RLE data, all that stuff. So it says that the number 2 is repeated 5 number of times in this whole process. So RLE of data is the total. Out of that, I am pulling out the second element of the list, which is the values. And out of that, I am pulling out the 160th element, which is coming out as 2. The number 2 is repeated a maximum of 5 times in this whole process. So we can very well execute these kind of functions also on the vector. And finally, one more important set of functions that we can look at with respect to the functions here is the sets. So where I can do some kind of set operations, right? So we can, for that matter, we can very well take x is containing 1 to 5, y let it contain 3 to 7, and z let it contain, right, 4 to 6. So these are the values. Now I can very well do the union. So I'll say union of x comma y. It means all the values included in x as well as y, but no duplicates. So 1, 2, 3, 4, 5, 6, 7. That is what is the union. Now when I say intersect of x comma y, the numbers that are the elements that are common to both x and y. So it should be 3, 4, 5. So these are the elements that are common to x and y. Now I can also do set difference between x and y. Means something that is present in x but not in y. 1 and 2 are present in x but not in y. Similarly, if I am doing set difference y comma x, something present in y but not in x. Now, if you look at this, if I am doing the union of these three, then it is equal to the union itself. Let me try this out. Union of x comma y. I want to find out whether it is equal to union of intersect x comma y comma set diff x comma y comma set diff y comma x. Are these two equal? Right, somewhere I union of intersect x comma y okay, union of x comma y. So these three I'm concatenating. Okay, these are vectors. Sorry. Now I'm trying to because these are not sets, I can't use union on the top of that. Right. So what I'll do is instead of union using union here, I'll say C of. Right. Okay, C of intersect x comma y. I think I have used one additional bracket. So I'm looking at C of intersect x comma y. So it is saying these two individually, it is saying false, 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 true, true. But what I really want to check out is, are these two fully equal? Means I am looking at with respect to all. Are all the values of this exactly equal to this? So I'll come here, close it. So it still says these two okay, I have to put all on the top of the stuff, not per exclusively to the right of it. I don't want to put it here. So per each one I'm trying to compare, right? For each one I'm trying to compare. So I'm doing this union of x comma y. Is it equal to C intersect x comma y, set difference x comma y, set difference y comma x? Alright, I'm trying to compare whether these two things are equal. So I'm closing the bracket, it says they are false because somewhere these two are not coming out to be the same. So why is it so? Okay, so I mean I have to put it in the same order because it would be comparing one to one. So first let me do it like this, right? All of union. So first let's do one by one. Union x comma y. I want to find out whether it is equivalent to C of, first I want to get set diff x comma y, which will be 1 and 2. Then I want to look at intersect x comma y, which will be 3, 4, 5. Then I want to take set diff y comma x, which is 6 and 7. So when I look at it only up to this, I get true, 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 true. Now on the top of it, I can put one all, because if all is something, when all of them are true, it will give me one single output as true. Even if one of them is false, it gives me false. So all is saying, yes, these two are exactly equal. So we can use different kinds of set functions like this even on the element. So which means there are different kinds of vector related functions that we can compute on our data, right? So this is what I really wanted to talk of. We really have a lot of things to do as a part of the vectors. Different kinds of functions, different kinds of features to be applied on different vectors. So one of the core things that you really need to have a grip on when you are working with R. If you have any further queries regarding this, you can very well get back to me by giving me a call on the number that I have provided below, or you can even send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.